You're watching NASA Edge, an inside and outside look at all things NASA.
Really great to be with everyone today for this special show. And I got to tell you, Franklin, we're in the middle of a global pandemic, but we're prepared. You and I, abnormally but safely distanced.
Yes.
We got our plexiglass shields. We're in the hangar at 836 at Vandenberg Air Force Base. We're on either side. There are hangar doors that are open, lots of air circulating. So we're safe and safe to talk about Sentinel-6.
Yes, and speaking of Sentinel-6, we have a 1/3 scale model as the centerpiece of our set, courtesy of our friends over at the Jet Propulsion Laboratory. But throughout the course of this show today, we're going to have subject matter experts from NASA, EUMETSAT, the European Space Agency, and at the end of the show, Tim Dunn, the launch director. He actually just walked in, so I can absolutely say his name and confirm that he is going to be here.
Like a rock star.
Like a rock, he did walk in like a rock star. So he's going to give us an update on the launch vehicle and the satellite as we prepare for our launch tomorrow morning.
But I tell you what, we're going to go to the pad now. The rocket is actually in the middle of the rollout and process where it becomes vertical and ready for launch. So we're going to stay tuned to that process throughout the show. But when we come back, we're going to have our very first guest from NASA headquarters. Joining us now is Dr. Thomas Zurbuchen, who's the Associate Administrator for the Science Mission Directorate. Thomas, thanks so much for being on the show today.
I'm excited to be on the show with you.
Appreciate it, because it's really an exciting time here at NASA. Earlier this week, we launched successfully Crew 1, and now we're about to launch this very important scientific mission in Sentinel-6. So I was wondering, could you tell us a little bit about Sentinel-6's overall role in NASA's science mission?
Sentinel-6 has a really critical role for all of us. It's part of the very important Earth System Science program that has close to 20 spacecraft in orbit, and Sentinel-6 is joining those spacecraft in orbit and doing a critical measurement, which is really all about the global state of the oceans, one critical system that really drives all of our lives.
Yeah, you know, it's interesting. We're in the middle of a global pandemic, but the need for this kind of science doesn't stop. How challenging has it been to keep this mission on track during these times?
So yes, we are in the middle of a complicated time, and you just have to be in awe of the teams.
Yeah.
What has happened, of course, is we put the safety of our people first, and our European friends do the very same. So despite that, and despite all these extra requirements, social distancing, contact tracing, and all these things, cleaning procedures, this team came in on schedule and on time. I mean, it's just absolutely on cost as well. That's absolutely an achievement that needs to be mentioned. The same is true with our rocket partner, SpaceX, and of course, Launch Services. They did it all despite it. It's been really hard.
Well, I'm glad that you brought that up, because really partnerships are very important at NASA. And on a mission like this, talk a little bit about the importance of not just taking this mission on ourselves as an agency, but really working with the scientific community and other agencies around the world.
I love that question, just because science is an international activity. We all look at the same sky. We all live on the same planet. And as a result of that, the best way of investigating it is together. That's therefore no surprise that 2/3 of our missions have international partnerships. This one is special over and above it, and it is a strategic scale mission in Europe, of which we're a 50-50 partner. So it's really a unique partnership with a symmetry that we normally don't have. And it really goes to say how important this is for both of our partners, both for us, but also the several European entities involved.
And it's true what you said. You're right. Science doesn't know boundaries. And so it really is kind of beautiful to see this all come together this way. You know, the last time we had you on the show was for ISAT-2. And you were going to be on console for the first time. So I'm wondering two things. Are you now a veteran at console operations? And number two, are you going to be on console for Sentinel-6?
I was on console on ISAT-2, and frankly, sitting right next to Mike Freilich, who was a veteran at this. His name, of course, is on this rocket, but everything went well with the final Delta II there. It was wonderful. I have to tell you, most of the times, I'm a veteran at launches now. I've been to many, but in most cases, I'm out there with our guests because the bottom line is I'm not the most important person at the console. I want our mission managers, the people who really know about these rockets to be there, and I stay in constant contact with them. And so for me, at the launch, I will expect to be out there at the gravel pit, as they call it, with the guests and also with newscasts, because I want to also participate in that together with our European colleagues.
Yeah, we're very excited about the launch broadcast tomorrow, as well as the launch. Good people working on that. Glad you'll be there. But you mentioned Mike Freilich. I want to know, how important is it to know that a colleague that you've worked with is being recognized in this very unique and special way?
Let's first focus on how unique this is. And the answer is it never occurred, ever.
Yeah.
And that is that the European partners basically said, we want to name our strategic spacecraft after your man, and to do that, all European countries had to sign up for that. And they did that, and enthusiastically so. So for me, I still think back of that moment when I was receiving that message from our European partners, and I'm still moved by that generosity of spirit from our Europeans. But the reason they were moved to do that is because of Mike himself. Mike, in all his life, kind of really showed the power of collaboration and really the respect of to our international partners and to partners all over. Through his life, he lived by the motto that was in his obituary, which basically says, my purpose in life, he said, is to make the world better and more beautiful, more meaningful. And that's what he did. That's why his name is there. And we couldn't be more excited. His family's going to be there. Why? It was one of his final wishes to his family that they go to this launch because it was so meaningful to him.
I tell you, special moment, special man. So excited to see this happen. Thanks so much for being on the show.
Thanks to you, but I really appreciate it.
Right now, I'm joined on set by Shannon Statham, who is the investigative and test lead for the AMRC on the Sentinel-6. Shannon, thanks for being on the show today.
Oh yeah, thank you so much for having me.
Now, the AMRC is a microwave radiometer.
Yes.
And can you tell me a little bit about how the technology on the radiometer has been upgraded from previous missions that are, observatory missions like this one?
Yes, absolutely. Well, Sentinel-6 Michael Freilich is going to continue a legacy of missions that NASA started nearly 30 years ago to observe our sea levels. And AMRC is the next generation of microwave radiometers. Every mission prior to Sentinel-6 has had a microwave radiometer instrument on board. And so AMRC is certainly taking the newest technologies and advancements in tools that we have available to us. And AMRC actually has two new technologies that are really important to the mission. One is an onboard calibration system, and that includes a rotating mirror. And that was specifically added because of some new science requirements that Sentinel-6 has that will improve the measurements that we've been able to take in the past, as well as a high frequency component that will enable us to get even better measurements at the coastal lines.
When you talk about flight hardware and things that start moving, a rotating mirror, something like that seems like the question is, did you have any issues working with adding that rotating mirror to the satellite?
Well, every mission is going to have its own unique challenges for sure, because we're always trying to push the envelope in pursuit of scientific discovery and utilizing new technologies and wherever it's applicable for the mission. So absolutely, I'm sure everyone can appreciate that when you start adding moving parts to anything, you're going to certainly increase the complexity, and you need to make sure to test it. You need to make sure that it's going to survive the rigors of launch and survive the extreme environments of space. And so we, absolutely had some challenges along the way with the design and build and test of it, but ultimately we were successful. We had a great collaboration, with our contractor Honeybee Robotics, and then my team at JPL assembled the onboard calibration system with the rest of the microwave radiometer instrument and successfully delivered for the project.
Now, your vacuum testing and the type of environmental testing that you did for the AMRC, was that done at JPL?
Yes, for AMRC instrument, we did all of the build and test at JPL, and that included vibration testing to certify it for launch, as well as a thermal vacuum testing to certify it for the temperature and vacuum of space.
Now, this is one of two satellites Did you deliver both of them to Germany for this for the integration?
Yes, absolutely. They were built in series. So we built one, delivered it to Airbus in Germany to go on the Sentinel-6 Michael Freilich that's launching tomorrow. And then immediately after, we built the second one and delivered to Germany again. And that vehicle is going to launch in 2025, so 5 years from now. And that will give us that decade-long record for the Sentinel-6 program in our sea level rise.
Well, it sounds great, Shannon. We look forward to a successful launch tomorrow morning, and we thank you for being on the show today.
Yes, thank you so much for having me.
Joining us now is Pierrick Villumier, who's the ESA project manager for Sentinel-6. Pierrick, thanks for being on the show.
Thank you for having me.
One of the big questions I have is, we talk about partnerships all the time with NASA, and this is a very important one. So could you tell us what's ESA's role in the Sentinel-6 mission?
The European Space Agency role in the partnership we have established around Sentinel-6 is the development of the space segment. So we are developing and building 2 identical satellites. The first one will be launched tomorrow here from Vandenberg, and the second one will go in storage and continue the mission in about 5 years to add in total about another decade to the data records of the sea level measurements.
Tell me a little bit about the instruments on Sentinel-6. You've made some improvements on previous similar missions?
Yes, we have a nickname for the altimeter. We call it Poseidon 4. So Poseidon was the name of the first altimeter that flew together with Topex Poseidon. And then all the altimeter have since been named 1, 2, 3, 4. So the 4th generation of Poseidon is, of course, meaning to continue the sea level measurement, but the technology has improved completely. The measurements we take from the altimeter can be processed in a traditional way to be able to compare the result with the previous mission. So we have really a continuity of the data there. But at the same time, because of this new architecture, we can process the data in some different ways and increase very much the along track resolution of the instrument. So we have continuity, but we also improve very much.
And that's got to be a big part of the challenge, especially when you think of things like follow-on missions after Sentinel. What comes next? Because we still need to continue this study.
Absolutely. Climate is a long-term process on Earth, and it's already remarkable that we have been able to measure over almost 30 years, and we know very well how the sea level is evolving. Now we want to continue with Sentinel-6, add another decade to this, but it's not finished. The climate will continue, and we are already thinking about next generation of the Sentinel-6. So all the Copernicus satellites are operational, and we are thinking of continuing their operation well into the 2030s and beyond. So there will be a Sentinel-6 next generation. We are looking very much into making sure that this new satellite will fit into a system together with other satellites. That's one of the key things we will add to the next generation. And we are now discussing with the scientists to understand which are their needs and how we could improve the measurements into the future. What is essential is to remain the status of reference for Sentinel-6. The orbit we are flying on is special in a way that we can compute out the effect of tides, and therefore the measurements we take are very, very steady, very accurate, and the data from all the reference missions, starting from Topex until today, they are also used as zero level for other altimeter like the Sentinel-3, for example, flying now on the polar orbit.
That's awesome. Thanks so much for being on the show, Pierrick. We really appreciate it.
You're welcome. Thank you.
Chris Gersh had an opportunity to sit down and talk with another important partner in this mission, EUMETSAT's Gareth Williams, head of flight operations in Frankfurt, Germany.
Gareth, thank you for joining us on the show today. What is your role at EUMETSAT?
My role at EUMETSAT is Sentinel-6. I'm the system manager, which means I'm responsible for bringing the different elements of the program together. I also have a broader role at EUMETSAT as the next head of flight operations.
This is an organization that's in charge of a lot of the Earth science satellites in Europe. Is that true?
That's right, yeah. EUMETSAT's an international organization that has 30 different member states from across Europe. And our job is to use satellites to observe the Earth's atmosphere and the Earth's oceans for operational meteorology, so weather forecasting, and for oceanography and to monitor climate change. EUMETSAT operates 9 satellites at the moment. We have 4 satellites in geostationary orbit. They take like the big picture of the Earth. Those are Meteosat satellites. We have 3 METOP satellites which operate in low Earth orbit. So they take the fine resolution data, and those 2 things are combined together to give a fully comprehensive picture of the Earth. And then on top of that, we operate 2 of the Sentinel-6 satellites on behalf of the European Commission's Copernicus program. Now, EUMETSAT doesn't just perform the flight operations for these satellites, we also operate the end-to-end data processing services. So we gain the data from the ground stations spread around the world. We bring that data here, we process it, we convert it from the bits and bytes of the raw data stream, turn it into the sensor data, so the time difference between the signal leaving the satellite, reaching the sea surface, and then coming back to the satellite. And then lastly, we turn that into geophysical data, which means we turn it into a height measurement.
Since you have a large number of organizations working together on such a complex mission, what are some of the challenges that you face as an organization in trying to meet the objectives and goals of the mission?
Well, the challenges are you're trying to bring together expertise and means of working from many different partners. EUMETSAT has its own way of doing things, so does ESA, so does NOAA, so does NASA and CNES. And trying to bring those things together is actually one of the main roles that EUMETSAT plays in Sentinel-6. We're the system coordinator, so it's our job to maintain the very high level definition of what the system has to do, and then to define all of the interfaces between the different partners so that the information flows around between the partners seamlessly and without problems. And doing all that is quite a challenge. And within each partner, you have many different computing systems, you have millions of lines of software code, you have expertise in different areas of the satellite, of the data processing systems, of the science as well. So it's a big job to bring all these things together.
And one of the great things about this mission is that you're going to be bringing important data, not only to the 5 different organizations, but you're going to be sending it out to the entire scientific community around the world to be able to use that data in their weather reports, studying climate change, and just seeing how the Earth is actually changing.
Exactly. There may be only 5 partners involved in the mission, but we are supporting a very large global audience of users who are waiting to obtain this information. It's relevant for the whole world. We're gathering data about the oceans from the whole world. EUMETSAT is disseminating the data to our 30 member states and across Europe. The US and NOAA and NASA are disseminating the data to the American users as well. But the Copernicus program is making the data available to a very, very wide audience. And that makes it a very useful tool for oceanography, for operational oceanography, for the fishery industries and for offshore industries, but also for predicting long-term climate evolution as well.
Well, Gareth, thank you so much for joining us on the show today. It's been great to learn a little bit more about EUMETSAT, and it's not just going to stop here with Sentinel-6. You have 2 different satellites, 2 different Sentinel-6s that are going to be launching over the next several years, and plus more satellites to come down the road. So thank you again for being on the show, and good luck with the mission.
Thank you very much. Take care, Chris.
As we take a look at Slick 4, the Falcon 9 is still horizontal at the pad as we are in the middle of the rollout process. And to talk more about what we're looking at right now, we have Launch Director Tim Dunn from LSP, who is here to give us an update on the status of the flight vehicle. When we talk about the rollout process and prep for launch, what takes place after the vehicle is, in the upright position between that time and the time that it launches?
So once we get the vehicle vertical, we're going to do some hydraulic checks, make sure that that strong back that the rocket is sitting on right now when it's horizontal, when we go vertical, we want to make sure that we got to bring that back away from the vehicle in those last 5 minutes of countdown. So we're going to test that out, make sure that all those hydraulics that operate that system are good. In the early morning, we're going to start getting more serious as we begin to man consoles. We'll test out the autonomous flight safety system, test out all the RF radio frequency systems on the rocket. We'll do prop checks, and then we're all targeting that last hour That's when it all really starts coming together, that's when we do all of the propellant loading on the stages. So we're gonna put kerosene, RP1 kerosene on both the first and second stages, and we're gonna put that densified liquid oxygen on the first and second stages. And all that happens in that last 36 minutes before launch.
Now, for those of us who are not familiar with Falcon X launches, Falcon 9 launches, or any of the other launches that we cover on NASA Edge, why do they load their propellant at the last minute?
So there's a couple of reasons. So for liquid oxygen, when you say you're liquefying oxygen, that means you got to get it super cold. And when we do that, we're talking minus 300 degrees F. So really cold. And when you densify, that means you get it even colder than that. So really cold. So you don't want to put these cryogenic propellants, super cold propellants, on too soon. They have a tendency to begin warming up. So because of this densified LOX, which you get a tremendous amount of energy when you densify liquid oxygen. So get a lot of energy out of that, and you're able to pack more LOX into the tank because of the densification. So you need to do that as late in the countdown as possible. So compared to some other vehicles that fly cryos, Falcon 9 is the one that loads it all at the last minute, and they get the most bang for the buck out of the rocket by doing that.
Cool. That sounds great. We just have a little bit over a minute left before we have to wrap up our show. But you talked about getting on console. As a launch director, what does your day look like tomorrow? When do you get on console? When do you start getting ready for the launch?
Well, once you let me go, Franklin, I'm going to head back to the hotel and I'm going to get in bed so I can get my crew rest started.
Right, there you go.
Because my alarm's going to probably go off about 4 a.m. tomorrow morning, and I need to be getting on console about 5:45 time frame, about 3.5 hours before launch. We're targeting a 9:17 a.m. Pacific time launch. So we'll get on console. I'll check in with my NASA team. I'll check in with the SpaceX team, make sure that the 30th Space Wing team is up and running. And so we'll just do a lot of communication checks, status checks, and we'll begin executing those last couple of hours of the countdown.
Good deal. Well, Tim, we're going to help you get to your hotel on time and wrap up our show. Thanks for being on with us today.
Thank you.
And for everybody out there watching, make sure you tune in to NASA TV for launch coverage of Sentinel-6. For all of us here at Vandenberg Air Force Base, you're watching NASA Edge, an inside and outside look at all things NASA.
1, 0. And liftoff of Sentinel-6, Michael Freilich, continuing a legacy of ocean observation and international collaboration to benefit all humanity.